Okay, so in this video, we want to use Adam's method. That's the explicit one. This is Adam Bashforth method to compute for y of 0.4. So given that this is the differential equation, so we have these starting values to use. And this is going to be categorized into predictor and corrector method because it's two-step method. We use this scheme to predict, and we use this one to correct the already predicted value of our y 0.4. Okay, so now the starting value x naught, this is our x naught, our x1, this is it, x2 0.2, x3 0.3, x4 0.4. Similarly, our y naught is y, y1, y2, and so on. So this is y4 that we actually want to find. Okay, so now first we use the predictor method to solve this one. So what does that mean? So we then first use the predictor method. Now by Adam's method, okay, so the predictor, okay, which is y, and we already know the predictor. So what we're going to do is now we're going to say for when n is 3, okay, because we want to get the fourth one, so n is going to be 3, because already you know that this is the predictor. The predictor is n plus 1, and we want to get 4, so this n must be 3 so that we can get y4. N must be 3 so that we can get y4. So that is the idea. So now when n is 3, we're going to have y4 indicating predictor, which is going to be equal to y3 plus h over 24. We're just substituting n into this this blue predictor scheme. Okay, so we're going to have 55 y3. Okay, we have minus 59 y2 prime plus 37 y1 prime, and lastly minus 9 y0 prime. Okay, so now this is what we're going to do. So we need to find the value of, we already have the value of this. Okay, so we need to find the value of this, and the last one. So that is y prime of 3 and the likes. Okay, so now here, okay, so our y naught, our y, that is the differential equation that we want to solve, is half x squared. Okay, so that is half xy, right? So that means that y naught, so this is going to be 1 over 2 x naught y naught, and our x naught is, you know what our x naught is, this is our x naught and this is our y naught. So this is going to be 1 over 2 times 0 times 1, which is going to give us 0. So that's same thing, that's how we're going to be generating for the rest of this y's. So y1 prime, have 1 over 2 x1 y1, so that's going to be half of, our x1 is actually 0.1, we have the values there. So on our y1, this is our y1, which is going to give us 1.01. So if I use my calculator correctly, I should get 0.0505. Okay, so we're going to get y2 prime, which is going to be x2 y2, and half of our x2 actually is going to be 0.2 times y2, that will give us 0.0 So if I use my calculator very well, this should give me 0.1022. Okay. Okay. So lastly, that is the y3. Okay. Prime. So we want to have x3, y3. Okay. So which is going to be our x3 3 times 1.023. Okay. So and so from my calculator is giving me 0.535. Okay. So these are the values that we have. Now we can then put all this value into this equation. Okay, just to predict, put it into this equation, and already we know that our h value is going to be 0.1 because the x value is moving at 0.1. You see, it is moving from 0, 0.1, 0. That means it is moving, its step length is 0.1. Okay, so now we then put the value of that into this predictor scheme. Okay, so we use this to predict. So this is going to be our y of 3, that's the 1.023, okay, plus our h 0.124. Then this is what we are using. Okay, 0.3. This is what we're putting all these values here. We already have them, just put them and we compute it. So now this is going to be 55 times 0.1535 35. Okay, then we have minus 59 times 0.1022. That's this value. We already have this value. Okay, now we have plus 37 of this value, 0.0505. That's this value. Okay, and lastly we have minus 9 times 0. Of course, that's the last piece for this one. So we just simply put all this value into this formula to predict it. So that's what we have done. And if you compute this one here in all of this, you put this one in. So I already have the value, and this is going to give me 1.0408. Now this is the predicted value. We have used the predictor to predict this value. Then we now use the corrector scheme to correct this value. Okay, so now for the corrector, so we can say by Adam corrector formula, that is this formula. Okay, this formula. Okay, so we just say when n is also 3, right? So we have that y4, that's C for corrector, it's going to be y cubed, y is y3, h124, 9y4 plus 19 minus 5 y squared, 9 plus y prime. Okay, so that is what we're going to have. So now we now begin to put all these values in this corrector scheme. So now, of course, we know that this is already 1.023. The h value is 0.124. Now this is going to be 9 times. Now this is y4, okay, which we know what that is. This is 0. Y4. So we have to calculate Y4. Okay, so we don't have Y4, so we have to calculate Y4. So let's just quickly calculate Y4 before we begin. Of course, we don't have it. So let's quickly calculate that. Let me use this one. So Y4 prime is going to be half X4 Y4. Okay. Of course, we know that our X4 is going to be, we already have our X4. Our X4 is 0. So now this Y4 is the predicted value. This one, that's the predicted, okay, which is going to give us 1/2 times 0.4 times 1.0408. So using my calculator, so this actually gives me, from my calculator, it actually gave me 0.2082. Okay, so that's what this is going to be. So that's the essence of using corrector to correct that. So now this has already been gotten now, so we can then simply supply that into the scheme plus 19. Why, we already have this as well, which is 0.1535 minus 5 times. Already we also have this one, 0.1022 plus the last y, which is 0.0505. Okay, so we already have all of this except for this that we just simply calculated. So now if I use my calculator to calculate all these values, okay, so from my calculation, this is giving me 1.0410. Now then, the final answer, Adams method, the predictor corrector method, this value, which is Y4, is actually 1.0410. So this is how to use Bashforth method to compute or to solve differential equation numerically. I hope you find this video entertaining and easy to understand. Thank you.